Rita Morgado for Silva. Is a hardware systems engineering manager at Elekta, and she is the prominent sustainability champion for Elekta.
Great. So thank you so much for the introduction, Janir. So yes, my name is Rita, and I work for Elekta. I've been there for 9.5 years, and a lot of familiar faces in the crowd, which is fantastic. I'm a mechanical engineer by background, and I'm actually affiliated with MRLinac. Sorry about that, but I am currently working as a hardware systems engineering manager as part of a team who is looking after some of our subsystems which form part of our Linac components. And today I will be talking about designing a sustainable Linac, and I'm going to talk a little bit about the processes and some of the things that we do currently in Elekta, and maybe some of our vision a little bit for the future on things that we can do better. So I'll just do a quick introduction on who we are, and then I'm going to give a brief introduction to the environmentally conscious design topic, and then I'll be talking about how we apply it in Elekta, and then I'm going to jump to the fun stuff, which is to talk about some real examples. And I think out of today, if anything, if you come out of this networking with a little bit more awareness, maybe some ideas to take away and implement in your companies, on your products, or even in your homes, that would be fantastic. And then I'll also touch on circular economy. And I know now from Janir that there has been a whole talk on circular economy in the past, so maybe that will not do it justice, but it will just be a very brief introduction on what circular economy is and some of the potential applications, and then we'll closing statements and some questions. So, Elekta is a medical devices company that was founded in 1972. It's actually a Swedish company with headquarters in Stockholm, and from 1972 for quite a long time they were really developing Gamma Knife, which is radiosurgery equipment. And it's still one of obviously the products that we sell, but it was later on in 2003 that it was, there was that first big product that was introducing that image-guided radiotherapy. And I might be saying some of the things wrong because I've got a lot of colleagues here that know more, but this was actually done, and I'll talk a little bit about the Crawley site specifically, which is actually how Elekta really got into the radiotherapy business. And then there's a little bit of a timeline on some key deliveries and products and milestones for Elekta throughout the years. And there's been a big focus on obviously improving the way we use our systems, in our software applications, and then down in the corner in 2018, there's a reference to our first high-field MR-Linac, which is one of the products that I was very happy to be part of the development team when I joined the company, and it was released to the market in 2018. So if we look at the family of products, they can really be organized in our Gamma Knives, as I said, the intracranial radiosurgery solutions, the Unity, which is our MR-Linac, so it's a combined MRI machine with our Linac, and our Linac is obviously what produces the radiation for the cancer treatment. And then we have our family of Linacs, and I'll show some examples. And I think someone before the talk said, I don't know what a Linac actually is. So a Linac is an abbreviation for linear accelerator, which is basically a product where you do create radiation through the acceleration of particles, and then you use it to treat cancer and tumors around the body. And what is quite unique is not just shooting radiation in a single position. You also have basically rotating across around the body from you, and you have the collimation. So there's quite a big control system around it with collimation, beam shaping, the beam generation, and the whole hardware infrastructure around it, plus obviously the software solution. Elekta also has brachytherapy solutions, which is a little bit of a separate family on its own, which is also a type of therapy that is used for cancer treatment, but it actually is, it works by implanting radioactive seeds in a tumor or in an area of the tumor, used a lot in prostate cancer, for example. And then we have the digital solutions, and then obviously the whole service aspect. So let's talk a little bit about our Crawley site though. So the first commercial accelerator that was actually produced in Crawley was back in 1953. And if I've got any of the dates wrong, I'm sure Peter Doherty will correct me. And that was done still with a company which is NEL. Then that company moved to the current site where Elekta is now still based, and that was back in 1961. It then became Philips Medical Systems in 1989, and it was bought by Elekta in 1997. And if you remember it was back then in 2003 that there was that big launch under the Elekta banner. So actually it's a site that has been doing linear accelerators for a very long time, and now obviously it's part of a global company with, more than 4,700 now, I think. So, and here are some of the views of the site. And if you drive past it, it's just really right next to Talas, and you've got this very shiny new building that looks fantastic. So let's talk a little bit about environmentally conscious design. So why is it important? I think all of us are very aware of the importance of sustainability in our lives, and by 2050 we are going to around have 10 billion people in our planet. So we need to have a smaller footprint to accommodate our growing population. And the UN really has defined in a set of 17 goals different areas of focus. And I'm not going to go into all the detail, but when you talk about the theme of sustainability, it's actually not just environmental sustainability, it's also in terms of social sustainability as well. So you'll see areas of poverty, the hunger, and so on. But what I'm going to be talking about today is specifically the environmental sustainability topic. And you can got here some topics like number 12, the responsible consumption and production, 13, climate action, and which are in industry, innovation, infrastructure on number 9 as well, and then number 8 with a decent work and economic growth. And I guess as engineers, we have a big part to play here in the sustainability. When we talk about sustainability, this is not something which is unique to our company at all. I think this is something that there's big companies that are having a very strong stake and showing a lot of advancements in them. And there's some examples of companies which we, arguably, could deem to be sustainability pioneers. And you've got Tesla, of course, releasing, big launch of electrical vehicles. Patagonia as well, with having a very strong mission statement as part of their brand and part of their company, and then a few other examples. And Elekta is really starting its journey, and I think there's been since I joined the company, there is definitely, I feel, an increased awareness and interest and a target around the sustainability topic, because there's a lot of pressure, and interest growing around the world. And I think, so when we're thinking about the societal impact and value versus the market impact and value, obviously you've got almost 3 different stages, which is we need, first of all, to comply. And I'm going to talk a little bit about compliance and regulatory decisions that we need to make. So we need to be able to comply to the right processes and to hit the market specifications and needs and requirements. Then it's around innovation so that we can remain competitive as well. And then it's about transformation to lead. So I talked a little bit about our Linacs, and here are some images of some of our solutions. So you've got the one on the bottom is our Unity system, which is our MR-Linac, and you've got then our Versa HD solution, and then our Harmony solution, which are part of the same family of Linacs. So when I'm going to refer now going forward with Versa or Linac, you're talking about these two versus the Unity, which is a much larger system with our MRI and our Linac included. And this is something which is quite unique to Elekta and companies who work on medical devices, because the world of particle accelerators is actually beyond medical. So when people hear about linear accelerators or particle accelerators, you're thinking about CERN, you're thinking about, particle colliders and systems that are really kilometers long. And we're quite unique because actually we're quite small in the world of particle accelerators, and we're very high volume in comparison. So usually when CERN is designing a particle accelerator or a linear accelerator, they're going to be designing one part of each, versus we want something that we can make the same consistently and often. But then at the same time, we do need to have some variety in our products because we have an ever-changing user needs, and we have different products for different applications, and then we also have different choices of design and materials as we progress and as things change as well. So if I was to wrap up in terms of our vision, in our high volume Linac business, we want to be able to reduce the CO2 equivalent footprint in the world, but we want to still be delivering the continual improvements in the standard of care for cancer treatment. And I think that's something really important because we will always have a footprint, we will always have an impact. So it's about minimizing that impact, understanding that impact, and then just have targets against it without affecting the performance of our products as well. So, okay, you've got a good understanding hopefully now of what we do. So what is it that we do, and what is it that you would have to do if you wanted to start implementing some environmental conscious design thinking in your company? The first thing you need, and the first thing that Elekta has been really focusing on, is having some high level targets. So what is the vision for your company? What are the areas you want to focus on? And here, touching on some of the points that the UN 17 goals talk about, you'll be having different areas we can have a focus on. And for us, there's been a big focus on reducing the depletion of natural resources. So like primary sourcing of material and components. And that can be done through limiting the use of certain materials, looking at the life cycle impact of it, also energy use, reduce hazardous materials choices, recycling, etc. Also the reducing the mass, reducing complexity, reducing number of parts as well, and then potentially extension of time of parts survival through improved reliability and efficiency, and then overall reducing that potential for pollution. And what you'll see here is that a lot of these themes are not unique to just sustainability, it's actually just good engineering. So there's a lot of things that will have benefits beyond sustainability and actually can bring other improvements as well. So when we are thinking about our own targets in Elekta, there's a lot of standards that we refer to, and here I'm highlighting some of the key ones. So ISO 14001 is one we comply to, and it's not just around our design, it's actually about having an effective environmental management system for your company, and it goes beyond your products. It actually goes for your infrastructure, for your company, and it goes for the whole life cycle. But then products specifically, we have got IEC 60601-1-9, which is part of our medical electrical equipment compliance for medical devices. And the parent really is the IEC 60601-1. And this one is really focusing on specifically requirements for environmentally conscious design. And then I've also included some very interesting publication on the NEMA standards that has a good refurbishment practices for medical imaging equipment as well. And then obviously we have our own design policy internally as well, which kind of brings things from all of this. So when we are looking at the IEC 60601-1-9, this standard really breaks it down in different things in terms of having the right roles in your company, having the assess the environmental aspects that you want to consider, prioritizing those aspects, involving looking at the supply chain aspect as well, not just your product design, setting those targets, and then having that evaluation. So how are you measuring it? How are you evaluating it? How are you basically saying that it's getting better? And then it also talks a little bit about the packaging and then having a lot of instructions and the recycling as well. So it's actually quite a good standard to look at, especially if you're in the medical devices industry, because it gives you quite a good framework and structure to work from. So that's the theory. So what do we actually do? These are some of the goals that Elekta currently has, and a lot of this is actually reported in our annual report. So if you're really interested to learn more in the detail of them, it's something that is available online. But there's 3 big areas of attention that Elekta is putting goals against. One of them is materials efficiency. And the goal currently is around establishing and implementing what they call a take-back program, which is already touching on that circular economy topic that I'm going to close this talk with, by a certain date, and then having a refurbishment program for reclaimed parts and components by a certain date as well. In terms of waste management, there is an ambition to have zero waste to landfill, and this is not regarding the products that we sell, but actually in terms of our sites, in terms of what we produce here in Crawley, and then also in the sites that also do manufacturing. And then there's a whole climate and emissions topic, which is much bigger. And currently, and this is not something, I'm not sure if you're aware, but there's this whole initiative which is called Science-Based Targets, which is actually a very good framework for companies that you can apply to have targets that get validated and measured externally from your company. And at the moment, Elekta is going through the process of establishing those targets as well. So stay tuned and look it up. So one of the big things we've done in the last year is that Elekta has gone beyond what they have ever before in mapping the emissions that we produce as a firm according to the greenhouse gas protocol. And when we are looking at the emissions, we are not looking just at our product, but our overall company. And there are, according to the greenhouse gas protocol, there's different scopes you can look at. So the scope 1 is really like the direct greenhouse gas emissions that you generate as part of your activities, which is basically your middle part here. So your facilities, your vehicles, your transports, and you're getting parts in, and maybe your factory, but also your offices, administration, etc. Then you've got your overall scope 2, which is called like the indirect emissions generated by the production of purchased electricity to run your infrastructure and your company, etc. And then you've got your overall scope 3, which is actually the remaining emissions, which are indirect, that are part of the overall value chain. So that also means you're transporting the capital goods and your primary sourcing, transportation, waste management, and then as it comes out from your factory, also as it goes to end of life, and then the usage of your products afterwards. So as an engineer, I do care about all of them, but I have the most power to influence is going to be scope 3. And so this is all well and good. So we've got these company targets at a super high level. So how do you use these as part of your day-to-day? What we found that works well is that we have to set targets and requirements against specific projects or products. And we have to translate these really ambitious and very high level targets into something which is meaningful and that we can measure and that we can actually design against. And when we are talking about product requirements, there are different aspects that I put here as an example. And I've touched a little bit on some of them before, but we can identify redundant or over-specified parts, for example. Can you reduce the part count where it's possible? Rationalize the number of power supplies that you have in your system, amount of cabling, minimize the weight of new designs through modeling and through optimization of design. Improving the ease of disassembly so you're actually recycling, recuperating more at end of life as well. Optimizing the amount of lead or tungsten that you're using for shielding, and I'll talk a little bit more about that in the future. And you can do this by, computer modeling, Monte Carlo, and a lot of activities that you can do now. Can we design our products to facilitate remote fault diagnosis and also have a reliable design? But all of these things are only meaningful if you have something to target against that is a measurable target, right? So part of having that measurable target requires having a baseline. And a baseline not in the sense of the overall structure of the company, but in terms of your product. So where is the biggest impact and the biggest CO2 from your products coming from? And this is something we've been working on over the years to build a better understanding and a better picture. And so when we're talking about having our baseline, we're talking about what is the impact of our current material use, our energy use during the life, and the overall life cycle as well. And what that enables us to do, and is something that we are iteratively improving on, is actually having targets against those existing product baselines. And then we have obviously also identified project opportunities and savings quantifications as well. So to build a baseline, you basically need to start with something. And this is like a print screen of some of the CO2 equivalent conversion factors we use. And this is information that is available online, and there's different sources for different conversion factors, and I'll talk a little bit more about that. Where you've got on the top, for example, CO2 footprint for kilograms, so kilograms of CO2 per kilogram of material. And you've actually got different values for the primary production, but then also for your manufacturing, depending on what you're doing in manufacturing, up to your recycling as well. Then you've got your SF6, which is one of the products we use for the running of our machine, the dielectric gas. And then we've got the electricity and the transportation picture here as well. And there's a few that really stand out, either by having an immense impact, like the tungsten, where the primary production, you're producing 66 kilograms of CO2 per kilogram of tungsten, and that's because it requires a lot of energy to produce and to sinter. Lead, maybe not such a bad impact, but quite a difficult material in terms of handling in a ROSH point of view, from a health and safety point of view. SF6 is a dielectric, taking the cake here in terms of the CO2 impact, really high impact gas, but especially this impact is on if you release it to atmosphere, but very recyclable as well. And then you've got your transportation here, looking actually quite low, and it's in comparison to some of the other factors. So what we started doing was to have a baseline for our different machines. So here's an example. We've got our Versa, our beautiful Linac here, and what we've done is we went through our bills of materials, and we went to measure how much kilograms of steel and tungsten and wood, everything that we use. And what you've got here in the dark blue is your mass of material versus your light blue in your CO2 equivalent. And if we have a little bit of a graph here as a relative comparison, something really pops to mind, which is that tungsten takes off 54% of our CO2 equivalent impact for our material, for the amount of material that we're using, and that's because of that factor that I was showing you before. And it kind of starts like, you start understanding, okay, there's a big potential here, this is a good area of focus for us. We then look at our MR-Linac, very different system, obviously, designed around an MRI, so the amount of steel is obviously much lower because you are working in a magnetic environment, so you have a much higher use of materials like stainless steel, for example, or aluminium. And actually aluminium here taking the biggest impact compared to tungsten. And tungsten being much lower in comparison to our Linac, just because of the type of design, the design choices that you make. So it's a machine which has a very different structure. And instead of having our beam arm like you saw in the other one, you've got here a rotating structure. And in the center, in the yellow, what you're seeing is really the MRI machine, and then your Linac is around in this gantry structure that rotates around it. And this impact does not include the MRI. It only includes the Linac structure around it. But then we didn't yet have a complete baseline. And this is like brand new information that some of the colleagues who are here today have been working hard to obtain, because we wanted to know more. Okay, so we know what's the impact of our material, but how does this actually, measure against, for example, the energy and the electricity that we're using throughout the life of our machine? And this is a plot that one of my colleagues has done, and it was calculated based on some nominal electricity consumption. And I'll talk a little bit about that, the fact that it can actually change. And you can see here that our electricity consumption really taking a big piece of the pie here. And this is looking at the overall impact throughout the life of the machine. and the lives of the machines, we're talking about 10 to 15-year lives of products here. But still, the tungsten showing up pretty high. And this is for our Linac, the one with the big arm. But then, one thing that was very interesting is that the energy conversion factors that we're using are really dependent on the country. And they're really dependent based on a national grid. What is the percentage of fossil fuels and renewable energy sources? And so my colleague Andre here did a very interesting and eye-opening comparison where we've got two very extreme examples of, we've got a Sweden on the left versus Iraq on the right. And so with Sweden, we've got electricity consumption actually only taking 2% versus Iraq taking 83%. Like, what an amazing picture, right? So it really tells you that the story it keeps getting more complicated and it keeps evolving. And there's other things also that can affect our electricity consumption, because we don't have control over how our customers are using the machine. So this is really based on assumptions and based on, okay, what type of treatments are they running? How is their hardware, how is their infrastructure set up? How is our air conditioning running? Are they using renewables? Are they not using renewables? So there is a lot of things that can really create that variation. And here I'm just showing two images of two other cases that we explored, looking at max rigid of our systems versus what we have considered to be a nominal running condition, and how, you know, changing some of those assumptions can really affect the picture. And it becomes quite an interesting problem to fix. But I think what is undeniable is that there is things we can do and should do to reduce our electricity consumption throughout the life of the machine. So okay, so we now have our baselines, right? So we now know, through this baseline process, we now understand, okay, there's some clear areas of focus. So then, and these are just indicative, I'm just trying here to show what could be type of targets or requirements that you could set up in your products. And I've got here a product A that could be an existing product versus a product B that would be something that we're designing from scratch, right? And so for product A, an existing, we could have things that we could do to, how can we optimize or reduce the energy by a certain percentage by switching something off in a standby mode, for example. You know, can we have a percentage of reuse of our non-wear tungsten by a certain date? And these are examples of what I'm trying to say when we have to have measurable and meaningful targets, to have something which is you can measure and you have a target date for. Because that's the only way we can actually say, yes, we're doing something good. But then when you're looking at a new product, you actually have even more things you can do, because there's things that you can even have a design with intent to reduce the, you know, the using of material that has got very high CO2 equivalent from primary sourcing, for example, or designing, you know, a Linac system to maybe enable a certain reuse of parts or refurbishment, because you're designing those parts with a longer life that you can then extend on. So you've got other choices that you can make as an engineer to really have those enabling moments. And talking about, and this is a graph that one of my colleagues from Service was very kind to share with me, and this is a little bit of a graph that was done on a cost versus time. And I think what he's trying to show here, and this is based on some data that we've collected in Elekta, is how much does it cost us to do a change in a concept design versus a detailed design development versus when we have a machine in service. And it tells a little bit of an interesting picture, i.e. it's cheaper to actually design with intent up front before you release something to market. So I now wanted to talk to you, I don't know how I'm doing with time. No, yeah, just carry on. I want to talk about some real examples of things that we've done that maybe will serve as inspiration. So an example of a material saving, this was actually done as part of our MR-Linac, which is our Unity machine that was released in 2018, as I said. And this was something that was done from scratch as a new development. So there was a requirement, there was a target to optimize and reduce the amount of shielding, specifically around tungsten and lead that we want to use. So the team actually spent a lot of time doing modeling and simulations with Monte Carlo to really optimize where you had to place the shielding to diminish the amounts that you're actually using. And you've seen the effects of that in the plots and the overall CO2 distribution that you've seen. So it's a very successful example of something which is done with intent. We then have another example, and this was done as a change for an existing system. So there was a beam attenuator material, which is a part that basically attenuates the beam and reduces the scatter radiation. They changed the material they were using, and they changed it to lead instead of stainless steel, which sounds a little bit counterproductive, because I did say the lead was a little bit, from a health and safety, it does have some handling concerns, but actually from a CO2 point of view, it's pretty good. And it's very easy to melt, and it's very easy to produce. So after all, there was an overall reduction, and we've got here the reduction of kilograms of CO2 per machine, which is pretty impressive. And it's just about having those decisions that you can make. So it's a little bit like, you can do this, and what's the impact of doing that change? Another change that was done was around our console desk design. So they designed a more integrated GUI. And there was a reduction from 8 monitors to 3, which is, again, very impressive. And another change that around the materials was eliminating manual papers. So actually the manuals that we produce with our machine, we reduced a lot of them by just providing them electronically and online, which is quite a simple change actually, but every little bit counts. Another area that we've had some improvements was actually on our packaging and installation. And this was a work that some of our colleagues did to really look into the most efficient freight modes that we did. So they changed from air freight to sea freight, which resulted in a much smaller carbon footprint, even though the distance that you were having to transport a good was longer. You also did some improvements in packaging material and designs, and reduced the number of screws, include fork slit access, and then did the last mile optimization project. So you're basically, just doing a very intentional design, an optimum design. And around this last mile optimization, this was a work that they did on basically having a very detailed item planning and the warehouse management as well, to track, install, to have all that sequence packaging and loading. And they wanted to have first time right, so basically you're not shipping something to site with a missing part, and you're having to then ship something later on as well. So it was just really like a logistics effort, but not a design change, but still the same. Another example here was more on the energy saving point of view, and actually the engineer who did this change is sitting here. And this was a change in our product where they changed the IE2 rated pump in our cooling system. So they reduced the electricity used by just using a more efficient pump. And you've got here again the CO2 savings that you did, and it was 30% less energy with a new pump. On supply chain, and this is again, we've got colleagues here from that work a lot in the factory, but there was a little bit, there was a lot of work done on our local production, Crawley, so we reduced carbon footprint, just shifting the build to local site as well. So just getting things done closer. We reduced a lot of wasted material and packaging as well, reduced the lorry movements as well, and then just the overall electricity consumption also dropped in the build and pre-test systems by simplifying the test procedures on site as well. And all those things, they really they do add up, because we make so many of those systems and we're working on that high volume, as I said before. And my last example before I move on to the circular economy was around our IntelliMax, which is one of the products we sell that actually enables our remote monitoring and machine diagnostics. And we are now pushing to do a lot of the remote software distribution. So a lot of the software updates can now be distributed electronically and installed remotely. Not all of them, but some of them. And then we have a lot more predictive and proactive maintenance because we're monitoring the system in certain conditions. So we're trying to, reduce the amount of downtime and also the parts that are being replaced unnecessarily. So, which is great. And then also with the remote access, you don't have the engineer having to go to site to actually do the fix, which you're reducing the traveling. Okay, and just to finalize a little bit, and I'll just give it very short introduction to circular economy. Circular economy is quite a buzzword at the moment, so I think there's a lot of companies looking at this, and it's really about reintroducing the value and reducing the waste into your supply chain. That's the easiest way to describe. So if you think about, you've got your more linear, traditional way of production from an extraction of raw materials, part supply, manufacturing, distribution, going to the end user, and at the end, that gets thrown out. You're now having the first loop, which is your service loop, so you're maintaining it, you're repairing it. You're then having maybe a potential refurbishment loop, a parts harvesting, and a potential recycling. And you can see as you have these loops, they feed into a specific area of your economy here. And I'll just give a very short introduction on each of those loops and examples. So in a service loop is really around the maintenance of the product over the lifetime of the solution. And this is something that you can do by taking development considerations in terms of like what planned maintenance will you need to do and how you'll react on a case where your machine goes down and how you're going to correct that. And you can do improvements on fault finding, remote support, designing with reliability considerations, and basically, trying to have less failure of parts of that system. On the second loop, you've got the product refurbished loop, which is about having a second life of a potential system, which is something that there's some medical device companies that do, mostly around imaging. With radiotherapy, it's a little bit more complex because we do have a higher radiation environment and like megavolts as well. So there is a lot more considerations to be had there on those systems. So then you have the parts harvesting loop, which is around reusing, refurbishing specific parts and components. And you can look at it in terms of that end of life of the solution, or as you're having your field replacement units as well. And if you were to do a parts harvesting loop in your company, maybe one of the things you could do would be a scoping phase, identify what are your high impact parts and materials, like we did in Elekta, identify which of those parts have wear out mechanisms, degradation mechanisms, and then you can have your strategy done for different parts. So maybe if there is no wear out, can you reuse that part? If there is a wear out, can it be refurbished or repaired or maintained and brought in? If yes, then you can maybe move it to the next stage. If you can't repair it, maybe recycle if possible. And if you can reuse, if you can refurbish, then you need to have your supply chain set in place. And you also need to have all your engineering assumptions and testing and regulatory work done as well, of course. And then in terms of recycling, this was us doing an assessment of recycling for a lot of the materials that we use in our machines. And just looking at recyclability of material. So SF6, for example, huge impact from a CO2 point of view, huge, very recyclable. So actually, when people recover it and you recycle it, you're eliminating a lot of that CO2 footprint. Steel is the recyclable material, right? I mean, it's recycled domestically already, and it's something that can be done very easily. The same with aluminium, the same with copper. Stainless steel is an interesting one. It is recyclable, but obviously you have different grades of stainless steel, so that's a little bit more of a consideration in terms of the identification and separation of that material. And then you've got lead antimony, which is a material we use for our shielding, which actually melts at very low temperatures, which makes it quite recyclable, and it actually is very energy efficient to do so. So again, a really good material to recycle. And then the plastics is such a big topic, right? And I think we do use plastics in our machines, especially in our cover sets and in our other parts. And in general, as a mechanical engineer, I know that thermoplastics are recyclable, but obviously your mechanical properties can get affected once they're recycled. So, because obviously you're affecting the polymer structure, but polyurethane is very hard to recycle, and I think that's changing. So usually energy recovery is a much more common thing. So here's a few reasons why you probably should look into circular economy for your business or for your company. It is linked to sustainability. There's also an economic advantage to it, but it enables you to reduce the overall product lifecycle impact. For us, there is an ethical responsibility as a medical devices company as well to look at our overall impact, and obviously it would potentially feed into our 14,001 compliance. So, summary and closing statements, and then we'll ask some questions. So, for me, as an engineer, I feel like we are responsible for thinking about sustainability in our day-to-day, and we are responsible for making those choices and to be able to track them and measure them. A lot of the things that we do that were done, that resulted in a sustainability improvement, sometimes are not even driven by sustainability. They're driven by a reliability improvement, a cost reduction, or so on. It doesn't mean they're less beneficial. I think it's still important to really measure them, and maybe there are things that you should be driving through a sustainability point of view as well. Having those baselines are also very important because they will really highlight the points of interest. And for me, and this is one of the reasons I'm here today, is that I would just like to increase the awareness of environmentally conscious design practices and just regulatory, and just promoting some ideas on how you could implement that on specific projects. That's it for me. And any questions?
Thank you, Rita. It's a really interesting presentation. Thanks very much. Any questions from the audience?
Yes.
Greg.
In the event you've got a potential environmental improvement which doesn't result in a cost saving, it results in an increased cost of ownership for the end user. How do you trade those? How do you trade that?
It's a very good question. I think ultimately every time we're doing an engineering change, we are always measuring the value it has. And there are things we do because they will give you a better performance as well. So ultimately, all you can do is just, find what is the optimum golden point of trade-off. And it's not a very easy one to give you an exact number, because there will be things that you still should do because it's the ethical thing to do and it's the right choice for the product and for society. But then also, there has to be a place where, having solutions which are also cost effective is also a value added to the society as well. So I think it's just having the right trade-off and understanding where is your cost base. Is that your biggest target right now? Is there a compromise that you can have? Because you'll have some plus and you'll have some minuses. So I think that's why we always try to measure it and monitor it on an annual basis. Because actually, that's one of the things we do. And every year we're doing an annual report and we go through and we say, okay, what are the things we've done that are plus and what are the ones that we've done that are minuses? And actually we find that more often than not, we have more good stuff than the ones that actually are not as efficient. So, and sometimes there will be a compromise because you will need the bigger part for reliability or for better performance. And in that case, that is the right engineering choice. But if it's not over-specified, I think that's really the key thing, is not having an over-specification throughout your product. That answers your question. Yes, Dane.
It strikes me you've got a lot of data on equivalent CO2 sort of percentages, but it strikes me is that there should also be a dollar value against that, because ultimately, if you're reducing the amount of energy consumed, you're optimizing the design. Yes, there might be some more upfront costs, but surely over the life cycle of the machine or the usage of it, you'd see a reduction.
Yeah.
But it's interesting that is there, an industry standard for if you're saving this much equivalent CO2, it equates to a particular dollar value or a pound value?
That's a good question. I don't actually know that there is, but I mean, for Elekta specifically, we do have some sustainability bonds, and there is like an ambition. So I guess inherently there will be a dollar value associated with it by hitting our targets. But that's that's a really interesting proposition, and it would strengthen the business case as well for it. So that's a very relevant question. Yes.
And the fourth one. Yeah.
Yeah, thank you. My apologies if you've covered this already, Rita, but how far do you consider the operating environment when you're doing these CO2 calculations? Give a couple of extreme examples, but these Linacs are put into concrete bunkers to operate with walls a metre or so thick. Concrete is a pretty unpleasant material from the point of view of CO2. You could arguably reduce the material in your machine by increasing the amount of radiation scatter and say to the customer, okay, you now need 1.3 metres rather than a metre of concrete.
Yeah.
You could reduce your EMC emissions by saying to the customer, you need to screen your walls.
Yeah.
How far do you take that whole environment into account?
So we take it all the way, and especially on the greenhouse protocol baseline, the bunker emissions are included actually, as well as the transport and the service, and that's a really valid point actually, because you're right, we could reduce the self-shielding and actually have just a bigger bunker, but ultimately, yeah, we want, so we look at it overall. With the bunker as well, there is a whole world out there where there's a reuse of existing bunkers as well, and I think that's, and that's something that is not completely within our control. So I think from an engineering viewpoint, for us, it's really about what's going to be the specification that we're going to give our customer for that bunker, for the radiation protection, and then basically design backwards from there. So that is the consideration.
Because a lot of these you're selling into existing bunkers,
Exactly.
and it costs, you lose the deal if
Exactly.
the customer had to rebuild the bunker.
So there is definitely a customer expectation and requirement there that we need to consider. Yeah.
Thank you.
Mike?
Apart from the measures to reduce the emission of SF6 gas to the atmosphere, is there any real alternatives within the sites for SF6 which are less global warming?
Yeah. Peter is like shaking his head violently, yes. The answer is yes, there are other options available, but it has always been a compromise of the performance, because SF6 is quite a unique dielectric gas because it's got very good electric properties, but it's also a very good coolant as well. So it has been the industry standard for a long time, but there is definitely a big push around the partner accelerator community to move away from it and to look at alternatives. But there also, again, is coming with a compromise on the performance potentially and your arcing, your stability of your machine. But it's something that we need to seriously invest into it. And I think if you look in the literature, there are other alternatives as well. But sometimes you've got a mix of gas as well, and and some of them might become also very difficult. So there's always, so there are alternatives. The answer is yes, but they come at a compromise of performance at this point. Yeah.
No.
So medical device industry is quite heavily regulated. Regulation and compliance is a huge aspect of it. And how much do you think regulation and compliance can hinder sustainability when there's certain countries out there, collective districts worldwide, where they actually refuse refurbished parts, for example? How much of that is a hindrance, do you think?
I think there's always been a big conversation around the refurbishment because of the regulatory constraints. And I think the reality, it's there for a reason. And I think ultimately when you're selling a medical device, those regulations are there in place for safety. So I think there's a little bit of, and I think there's a big trend and there's a shift of understanding of refurbished. And actually, and this is very important, the concept of something refurbished is also very specific to the situation of that part. For example, you can refurbish a part to a state as new. And if that's the case, then if you say this part still meets original specification, it still meets the same warranty, the same life, the same everything, it can actually be deemed and qualified as a new part, versus a part that you refurbish but has a different performance and it has a different lifespan as well. And those are treated differently, even from regulatory points of view from the countries. There are countries that are very much like, no, we don't want to get it. China being a very difficult country to get parts back into, but then internally having a huge refurbished and repair market in itself. So it's definitely a constraint, it's something we have to consider. But I also think working in the medical devices industry, you get very used to it. It's just part of the job to be able to find the right compromise. And maybe there are things that don't work for every single country, but then it's also a choice to make it for specific markets or, yeah.
And do you think the research and development that you do as part of sustainability at Elekta can kind of almost help regulatory and compliance kind of catch up, because there is more, in certain industries, there is a bit of a lapse.
So there are people in Elekta who are very involved in the IC boards and the ISO boards as well. And just this week, I actually had one of my colleagues asking me to help him to review some of the regulatory. So I think the answer is yes. And I think it's just a continuous learning and improving of this regulatory as well. So yeah. And actually there is a BS standard that was released a few years ago specifically on circular economy as well. Practices applied as well. So it's all catching up, and actually having regulations usually helps because it also forces companies to have to do it and prove it how they're doing it, actually, yeah.
Like that.
A question about performance, how you evaluate performance of the machine. Suppose you come out with a new development, it saves more lives, cheaper, but it uses more tungsten, more electricity, you can't recycle it, this, that, and the other. How do you balance one against the other?
I think very similar to the question. I think, what I found out through the work that we've been doing in the company is that I don't think it's an all or nothing approach, to be honest. I don't think you have to say, oh, we have to do this, it will become inherently unsustainable. But I think ultimately, we are here to treat cancer. And I think that's the main focus of Elekta, is to give solutions that do treat cancer and doing it in an ethical and sustainable way. So if there is a new solution that we haven't yet conceptualized that, yes, has a bigger CO2 impact, but is treating more patients, why not doing it? And actually, one of the ways we measure, it's about not just the total baseline for the life of the machine, but also the impact per treatment course actually is our metric. So how many people are you treating on that machine over the life of that machine? Because that's ultimately the metric that we really care about. So if currently our machines are treating 100 people for the life, if we can have a new solution that is exponentially has more CO2 but can treat 10 times more, then actually you are shifting some of that CO2 because you're treating more patients and delivering more treatments. So that's actually how we balance it out. How is the thing that we're developing and doing enabling you to treat more people over the life of the machine? So that's personally for Elekta specifically, that's how we balance it out. Yeah.
Just one at the back.
Electronics, presumably you have electronics in the system. Have you any solutions to how to keep them refreshed and upgraded without having to swap out PCAs and scrap them?
I'm not really an electronics engineer, but we do handle a lot of obsolescence and keeping them refreshed. A lot of our electronics, not all of them, they are replaceable over the life of the machine because they do have to live in radiation environment, which is quite harsh. But in general, our electronics team does a really good job at just keeping up with it. And fundamentally, a lot of our electronics is used for the control of the Linac. So, and I'm just gonna look at Pete. He probably knows the answer better than me. But it's just obsolescence management, and I think.
Okay, thank you.
Sorry, it's a very, very, very bad answer.
Steve?
In one of the examples you mentioned, in the beam attenuation example, you did mention swapping materials for another one.
Yes.
Is there like a measurement you guys have done comparing maybe the quality or durability of the product compared to maybe using the old material so thin?
Yeah, so for a material change, for this one in particular, the engineer looked at it from a stress analysis point of view and from a weight ratio point of view as well. So that would be a very classical mechanical engineering thing to do. And then I think that what was important and what was unique was that they also looked at the CO2 equivalence as well. So they were looking at it from what is the alternative materials that I can do that can still meet my strength requirement and my weight requirement and so on, but also give me the least amount of CO2. So that was just a trade-off, which is quite a normal thing to do when you're selecting a material full stop, I guess, for mechanical design.
Greg?
Sorry, to come back to a few of the questions you've had, it kind of feels to me that if you were sort of trading CO2 emissions versus how many people you can treat how well for $1,000, some sort of effectively accepted carbon pricing regime would be very useful. Do you have a functioning carbon pricing that you can accept with your customers?
Yeah, so this is part of a lot of the science-based targets initiative that we're currently submitting for. Elekta has actually put forward some targets that do have some ambition in terms of the footprint for that treatment course, which basically has that carbon pricing, but it hasn't really been announced yet, and I was told I can talk that we're doing it, but I can't show any of the actual targets. But that's why I was saying, like, stay tuned. I think it will be launched in our annual report, and they're going to be talking about what our targets are going to be in terms of reduction, in terms of what would be our target to have that as a CO2 equivalent per treatment course in a certain period of time. So yeah, the answer is yes.
Yeah. As you said, Elekta is a Swedish company. It's listed, its primary listing is on the Nordic Stock Exchange. Nordic investors are particularly keen on environmental improvements and stuff. So I can understand that Elekta's shareholders are banging on the door saying to Elekta, you've got to improve this.
Yeah.
Does that apply worldwide? I mean, how are your American competitors or your German competitors? Are they under the same sort of pressures, or is this something that...
So, I mean, I don't know if they have the same pressure, but I know, for example, that Variant, who's our American competitor, I guess, now GE, they have had a strong sustainability messaging for a while as well. And they also have a sustainability focus on their annual report. But I think they are living within the same existing constraints as Elekta. I don't know if, similar to Elekta, if they have had sustainability bonds associated with them. I'm not aware that they have, but I know that that's obviously, you are absolutely right. There is a big pressure from the Swedish market, and I think, that it's a good thing, though. And I think it kind of pushes the company to having to really respond to that, which for me is like fantastic, great. And Greta will apply pressure on all of us.
Is there anything you can't change by reducing carbon that will affect, say, certification or intellectual property? Is there something that you're not going to touch?
In terms of our products?
Mm-hmm. So if you change it for a different product, you have to go for a recertification process, and bloody lawyers will take those money.
I think it depends. So for us, it depends on the impact of the change. Thinking here as a system engineer, if what you are changing can have a potential impact in the performance and the safety of your product, you might need to recertify, right?
Does that strike out all the costs that we save?
But a lot of the, but that's why it goes back to the graph where doing a change, doing development is the best time to do a change. So we haven't actually been in a position before, to be very honest, where we have done a pure change on sustainability that have allowed a recertification. I think that would be a big decision. What tends to happen is if there is a change that requires recertification for our products, you end up bundling those with other things. So, you know, you wouldn't just do, I can't imagine, at least right now in the world we are in, that we would just move ahead with a single sustainability focused change that would require recertification of the product, because as you said, that requires a lot of effort, a lot of engineering hours as well. But for me, like, my biggest focus is actually on the concept design, and that's why we need to catch the big decisions we have are doing that concept design, and then also doing that detailed design and development, having all of our engineers having the thought when they're picking the material and they're making this part and making design choices, when they're writing the specification, even if we're outsourcing that design, that they're basically saying, please consider this, this is important, you know, this is maybe a target we have against this particular part as well. So it's about having those value texts and those specifications, those requirements, not just based on cost, which has been something we traditionally have done, but also have a carbon cost, as some of the colleagues have alluded to. Yeah.
Thank you, Rita.
All right.
That's all from it. Thank you very much. On behalf of IT Sussex Network,
I have a gift. I love it. I didn't know. I'm not being bought, I promise.
Thank you very much.
Thank you so much.
It's useful to talk. Okay. Thank you, everyone.